Good afternoon, everyone. My name is Dejan Donek, and I'm the president of the ASCE chapter here at DU. Today I'm going to give you a quick overview of what was going on in the chapter this past year, all the events we have hosted, the competitions we have went through. It's pretty much a detailed overview of everything that was going on in the chapter. Before I start, I would like to thank our faculty advisor, Professor Stanley Bielovitz, for guiding us and mentoring us throughout this whole process, and for his efforts to try to make his chapter a lot better. Because if it wasn't about him, I would not be standing here right now talking about his success. So let's give him a round of applause.
That's worth 5 points.
2 hours.
There are a couple of topics I would like to touch on today. First was field trips. We had 2 field trips this year. One was to the Red Bull Stadium, and the other one, as Benson mentioned, was to the water filtration system in New York. These trips proved to be of big help for us because not just from the experience point of view, but also helped us visualize what was going on the job site. Because here we design bolts, we design concrete structures, but we don't really see it. We design reinforcement, but going there on the actual job site, we kind of get a visualize how everything looks, how everything is built, so it helps from that point of view. Here's some pictures. We see a lot of, as Benson said, the concrete. Obviously, he mentioned it's going to be a lot of concrete on it. Huge piping. This is the actual reinforcement. They have the beams laid down. Then on top of it, they're going to put another layer of reinforcement that is going to go horizontally. The bolts. I remember when I saw this, I was like, oh my god, those are huge bolts. And then, like a light goes into your head. You go like, wait a minute, I know how to design this. I know why these are here. I know why the spacing is right there. And it kind of gives you a satisfaction level because you know the whole concept of why the things are built the way they are. The next topic I would like to talk about is the workshop for student chapter leaders. Each year ASCE has a workshop for student chapter leaders, which each year is held at a different state in a different town. This year was in Atlanta, Georgia. In February 2010, FDU had 3 representatives going. It was myself, Sean, the vice president, and Arkar, the ex-vice president, who attended this weekend. Workshop for student chapter leaders, pretty much the title says everything. It is a workshop where they give you the tools and teach you how to make your chapter more successful, how to lead the chapter, how to organize the meetings, how to attract new members. Besides that, you have about 500 people over there from all around the country, and it is a huge networking opportunity. Exchange numbers, exchange cards, and only half of those people are students. The other half are people that work in the industry, like vice presidents, owners of companies, engineers, and it is a really good opportunity to meet people and pretty much hand in your resume. Maybe you're getting a good job. ASCE Metropolitan Area Conference. Each year ASCE has competitions. They consist of regionals and nationals competition. The winners of regionals competition go on to nationals competition. This year, FDU had the opportunity to host the Metropolitan Area Conference. Some of the schools we competed were FDU, NJT, Rutgers, Stevens, Columbia, Princeton. So it's a pretty good amount of schools, and schools that are in the top rankings throughout the whole country. It was Friday, Saturday, Sunday, April 23rd to 25th. April 23rd was so-called presentation night. On Saturday we had the steel bridge competition, and on Sunday was the concrete canoe competition. The agenda for the presentation night was the technical paper presentation. That was first. Pretty much what this consists of, it's a technical paper where each school has a representative that is going to present this paper, and each year it is on a specific topic. This year and past year was engineering in 2025, which more leads on towards lead structures and how it's going green. It's going to help us, and it's going to pretty much make the future of engineering better. Then we have dinner, and after that is the business meeting where the winners of the technical paper presentation are announced. And after that, the big topic of the business meeting is discussions where the next year's conference is going to be held. But I'm going to talk about it at the end of the presentation. And then we have the concrete canoe presentations, which each school has a team of 4 or 5 people that is going to present how the concrete canoe was built, what mix was involved, how, what kind of mold did you use, pretty much the whole process of building the actual canoe. I'm going to jump to Sunday because I would like to go chronologically. The concrete canoe, the actual competitions. Obviously, it's a canoe, so it needs to float. A lot of you may ask, well, it's a concrete, how is it going to float? It's all playing around with the mix, pretty much. You need to have mix which unit weight is going to be less than the unit weight of the water, so it floats. Our concrete canoe, some physical properties, so it was 20 feet in length, the depth was 15 inches in average, the thickness a half of each inch in average, and the weight was 210 pounds. The engineering properties, the unit weight was 55 pounds per cubic feet, the compressive strength 1350 psi, tensile strength 670 psi, and the flexural strength was 1390 psi. And this is a finished product, how our canoe looked at the end when it was finished. The actual race this year was at Denville, New Jersey. Before canoes are allowed to be raced, they need to follow specific rules and specifications. If they do not follow those rules, points are going to be taken off. One of the big tests is the actual swamp test, where you fill out the canoe with water and it needs to float. This is an actual picture of our canoe being filled out with water. This is a proof that the unit weight is actually less than the unit weight of the water, so it floats. And you have 3 races: slalom race, sprint race, and the co-ed race. I have some pictures of that. This is the actual slalom race. We see the buoy right there on the tip of the canoe. So this is the girls from FDU. They have to go around the buoys. This is preparing for the sprint race. We see how they're all aligned. The sprint race, you go up a couple hundred yards, and then you turn at a buoy and come back. Whoever's going to be first at the finish line, that's the winner. The still bridge competition. It was on Saturday. It was held right here at the campus, right outside the fitness center. Just like the concrete canoe, there's a rules and specifications for the still bridge. And if you do not follow those rules and specifications, you're going to be either disqualified or points taken off. Just one example, the Canadians, they probably had one of the best bridges here, but they were 2 inches short, so they were disqualified. The actual building of the bridge, each school has a crew team which consists of 5 members, 3 runners and 2 runners and 3 builders. And the way this works, we see all these lines, different lines here. The runners get the actual steel members from this side and bring the steel members up to this point. If they step on the line, there's going to be points taken off. These 2 marks here, squares, are where actually the legs of the bridge needs to go. If they do not fit, there's points taken off, of course. Well, the builders, they cannot step on this line right here. If this line right here. So you see this guy, he has his knee right next to the line. If they step on that line, there's points taken off for that. If they actually drop a bolt or nut, there's points taken off for that also. And there's 2 tests that apply after the bridge is being built. There's a lateral and a vertical load test. These are pictures from the vertical load test. And the way it works, first you load up the first side of the bridge, then the second side of the bridge. Total load is 2,400 pounds, and the way you measure the deflections is with a string pass. You see right here. The good thing about the string pass is that they measure the deflection directly in inches, so you know exactly what kind of deflection you get. And there's a good picture of all of us who participated. This year's FDU did not have a steel bridge because we ran out of time. With organizing everything, we just didn't have enough time. However, we have the design down, we have the steel, so we're gonna try to get a bridge for next year. 2011 ASCE conference. As I said, on the business meeting, it was discussed where is it going to be held. There's 2 options. At the business meeting, there's an open call if there's a volunteer school who wants to host the conference next year. If there's no volunteers, the hosting school can ask to re-host it again next year. Before the competition, we all got together as a chapter and decided if nobody asked to host it, we're going to try to host it again. We're going to ask to host it again. And since there were no volunteers, we did, and we got to host it again. And to be honest with you, we are pretty excited about that because this year we had a lot of fun with it. It was hard, but at the same time, it's putting our school out there. You get to know people from companies, and pretty much you benefit on every single point. And this year, we believe next year, we believe we're going to host even a better conference because we have the experience from this year. We know what was there, what was missing. We know what to improve, so we look forward to it.